mentioned before. Anyone have a question, so please be free to ask me during the presentation. Thank you. You can go ahead, Mazen.
Okay, thank you, Tugdar. It's my pleasure to give this short lecture or short webinar to the ECU University. This lecture is about production logging tool and pressure transient analysis integration. The logo of AllServe is put there everywhere because recently I'm working for AllServe, which is a service company operate in Middle East, like MENA region, like North Africa and Middle East only. It's originally established in Iraq, but it's expand later. The objective of this lecture is to explain in general the operation and delivery, like the final delivery related to production logging tool, pressure buildup, and injection logging tool with pressure fall-off jobs. No detailed analysis theory and no software training will be presented. Because some people sometimes, like there is a special course for software, there is a special course for theory of interpretation. This course is intended to give the big idea. What is happening there? What is the software? What we will get? What we will deliver? What is the problem? Why we are doing this one? So as I said, feel free for everybody to ask any question during the lecture. It is like open discussion lecture. So the agenda, there will be personal introductory for myself, conventional production logging tool components on convey systems, preferred analysis software, integrated PLT and pressure buildups, injection log tools and pressure fall-off operation, field data output, benefits of PLT and PTA integration. PTA is pressure transient analysis. Maybe I didn't mention that. Final PLT PTA integrated report contents, final soft data delivery, practical PLT and PTA principle and software proficient reference. I will give some kind of reference for the people that have interest in such subject that will be practically in use for them. Personal introductory. I'm Iraqi, born in 1980, holding a master's degree from University of Baghdad, Petroleum Engineering. I finished with Dr. Ahmed, my bachelor degree. A cumulative 16 years upstream experience, geoscience, drilling, and sales. I mean oil field specialty sales and technical sales. Since 2004, I started my professional career in oil industry with the National Oil Company, Basra Oil Company, Iraq Drilling Company. Then I moved in 2009. Actually, I forget to mention this one. I moved to Schlumberger Smith. Then I'm Varel, Baker, and presently I'm senior geoscientist with AllServe. My current duty is leading the technical geoscience support, tech marketing, upsell, cross sales for wireline product with South Iraq major contract and Kurdistan client. If everybody heard me, what is the difference between upsells and cross sales? Can anybody give the difference? Hello?
Even me, I don't know.
No problem. Like upsells, like you have a contract with fixed volume, like this contract, like have fixed volume of money, and your fixed job like is making, for example, 200 job. Upsell is to promote your jobs to become like, for example, 250 jobs during the contract period. Okay, this is called upsell. Cross sales, your contract have some kind of fixed technology. For example, you are only giving open hole jobs. Okay, but you make a cross sell putting another technology, like for example, you start to make like PLT jobs using the same contract. So that's called cross sales. You bring different product using same contract. Okay, this is the difference between upsells and cross sales. Tech marketing is like you go, you present your product, but you don't talk about money. We have this technology, we have this case study, we have this one, but never of any subject related to money. Major support client interact during my career path. I deal with BP, Eni, Hunt Oil, DNO, MOL, OMV, Exxon, Look Oil, PetroChina, CNOOC, national companies in Iraq, Basra, Misan, small operator like Ganel, Gulf Keystone in Kurdistan, Oryx in Kurdistan, HKN, Western Zagros, Talisman, Kuwait Energy in Basra. And also we dealt with the mega surface company like Schlumberger, like sometimes these surface company like Schlumberger, Halliburton, even Baker Hughes, they take a very mega project. It's called integrated project. So what's happening, they behave instead of the operator. They take all the rig, they take all the equipment, and they start the purchasing. So they call this like IOS, Integrated Operation Services, IPM, or Integrated Project Management. You'll find this one with the big company. Even Allserve, they take some kind workover integrated project management. They have some active integrated project with Eni, and previous one with ExxonMobil. My software profession, I'm focusing on Emeraude, Plato, both of them doing PLT analysis. Emeraude is more extensive software, and you will see that later. Saphir, which is well testing. This is one, it's amazing software, this Saphir. It's for well testing analysis. And Geolog, which is integrated open hole software. It's also have functionality to do some kind of formation testing analysis, cement evaluation. They try to make it integrated software, even PLT analysis, but nobody use it actually till now. Maybe in the future.
But the Saphir is the only one for well testing. The other one,
Okay.
well logging, correct?
Okay. What's happening right now? If you heard about TechLog,
Yes,
interactive petrophysics, and the Geolog, all this software initially was meant to be for open hole interpretation.
Okay.
What's happened later, they start to integrate a cased hole interpretation inside them, a geomechanics interpretation, even drilling things. So right now, if you open the Geolog, you can make full PLT interpretation directly. If you open TechLog, the same, IP the same. The reason for that, like it's come from operator. Like operator, they said, okay, I have Saphir, I have Emeraude, I have Plato, I have 10,000 software. This is not practical. Give me one software, I can do everything. Because this software, like Geolog, TechLog, for operator side, it is not only for interpretation. Actually, it is a database software. Like if you go to BP office and you open TechLog, you will find Rumaila project and all the wells from where Rumaila is there. But when they make PLT interpretation, they have to export all the data from Plato to a format that's accepted by TechLog, which is tedious. So it's better if they can make everything inside TechLog itself. Same is for Geolog, which is used by Look Oil, Eni, too many other operator. What's happening with Kappa nowadays, they already did actually. They integrate all the reservoir engineering, like rate analysis, pressure analysis, PLT analysis, what's so called PVT analysis, formation testing analysis. If somebody there can give me what is the difference between well testing and formation testing? Can anybody give me the difference in this name? Hello? Nobody answer.
They lost the car. It was a...
Hey. Student, where are they? They can't answer anything, you know, it is not something, it's not, they can't answer like, okay. The difference between well testing and formation testing like you are running during open hole. You run a tool called MDT from Schlumberger, RSI from Allserve. You put a probe and take a sample and make a small buildup for a small point, okay? And you have this formation tester. well testing, it can be done on bigger, like on bigger scale, by DST, by wireline, by silic line, using different sensing, but it's not attached to the formation itself. I didn't put anything about formation tester here. Okay, we'll focus only on wireline tool or PLT with. Okay, so this lecture is about utilizing the conventional production logging tool components. It's not because there is more advanced tool, the production. There is a multi-array probe tool, which can be used for more advanced application when you have a very sophisticated flow regime in horizontal or especially in deviated well. Horizontal well, you will have a good flow regime, but in deviated, highly deviated, this is the problem. However, we'll focus on conventional production logging tool and how we will convey this tool to the target zone. So before I go to this slide, anybody can tell me how we will convey, how we will take our tool and reach it, transmit it to the targeted zone? What we can use? Which type of truck? What do you expect?
I think I showed them in the video once.
Yeah, we can use a wireline truck. We can use a silic line truck. We can use a cold tubing unit. What I'm showing here, this is a wireline truck doing a rig job. This is a silic line job doing a rigless job, which can be done also same. Everybody can do this rigless and rig job. This is a cold tubing unit doing a rigless job. So PLT string can be run using silic line, wireline, or CT trucks. There is no difference. Silic line will provide only memory recording. We cannot do a real-time recording. Wireline and cold tubing convey can provide a service readout. This is the oil industry name. We can call it real-time recording and a memory recording option. Silic line and wireline can convey in wells that deviated up to 60 degrees because they run by gravity. There's nothing you can do there. There is extra option which is tractor, but I didn't put it here. Maybe next time.
Is that for direction well? When you say 60-degree wells? SL?
Yes, yes,
okay.
Yes. Okay, let me put the tractor option. I forget to put the tractor option. No problem. So what I meant, silic line and wireline cannot convey the PLT tool in wells more than 60 degrees. When you run in the tool in the well and you reach to the 60-degree deviation, the tool is stopped. You cannot push it anymore. So what you need in this case, you need the cold tubing unit. You can see my mouse? Sorry, you can see my mouse?
Yes, we can see that.
Yes, yes. My mouse wasn't on this screen. I was on different screen. So when you have a wells, horizontal or highly deviated, more than 60 degrees, you will need to use cold tubing unit to get your PLT tool to the target zone. Few points here. Silic line is the most cheapest option. Even the data quality is comparable with the silic line and cold tubing. There is no difference. And also, you need to send a senior wireline engineer with the silic line job, with the tool, to connect the tool. And then he will be, after he runs the tool on the memory, he cannot see anything. After he gets the tool on the surface, he needs to extract the data using a tedious operation. It's very tedious operation to get the data from the memory tool, but still cheap because it's run on silic line. CT or cold tubing have two options to run the logging tool. Either it's run blindly, like the silic line, it's mean on memory, or there is another option, newer option, is called e-coil, which is exactly will get the data on the surface real time like the wireline unit. The e-coil is super expensive option, but sometimes some company they willing to pay because there may be in horizon too much risk to lose the tool, so they prefer to keep watching what's happening down there. For memory job, this can be also done on wireline, even there is no need for that. Only in some special cases, you want to get some kind of full spectrum data from special logging tool like optical tool. You will run a memory tool on wireline sometime. I hope this one is clear. Okay. This is how we take our tool downhole, 3,000 meter, 2,000 meter, 4,000 meter. You will need these kind of convey systems.
So Mazin, when you say cheap, how much?
You can say even $10,000 or $8,000.
Okay, $10,000.
You know?
And is
Yeah.
that for one day job or?
Yeah, it's morning job. They go in the morning, they run the tool, make few passes,
Yes.
come back in the afternoon. But the engineer will stay 24 hours. Okay, we have one PLT project, memory project with BP. Like the job, the silk line job, in the morning, he go, maybe in 5 or 6 hours, he finish the job. He spent 24 hours just to get the data from the memory, to synchronize the data with the track data, depth data, with the time data. It's crazy, you know. But for wireline, even it's much higher price, but not really much higher price. Okay, maybe 3 times, depend on the contracts and above. You go there, you make your passes, and you get your passes real time during the track, and from the track he send the data. Okay. Usually, what I saw for silk line memory job PLT, they do it for injector. They don't want to spend too much money on injector wares. So they said, okay, no problem. Let's do the injector with the memory jobs. We are not such hurry for the data for the what you call it, injector wares. For cold tubing, what I saw, they do it mostly for horizontal well. Like e-coil job with multi-array easily can reach to $250,000, $25,000 easily.
For
For a
horizontal
single one.
well? For horizontal
Yes.
well, okay, almost that, more than double.
Yeah, for horizontal wear, 25,000, $250,000.
Okay. Oh, yeah. Oh.
Yeah, for PLT job on e-coil, $250,000. You can imagine this one.
Okay.
Yeah, so it's really, really expensive. Unless if the company have maybe the volume of jobs, what mean by volume of jobs? If your contract saying you will do one job, okay, per month, you need to make high price. Why? Because you will reserve the truck, the crew, everything for this company to do one job per month. So you need to go high price. But if the company told you, I will give you 20 job per month, you can highly reduce the price because the volume of job will get a revenue for you, a profit for you. So this is what's called volume of job sometimes.
Are you talking about well logging in horizontal well or well testing
In general,
in
in
general?
general.
Yeah.
Yeah, in general, for not only for well logging, for everything. If the contracts mention a volume of jobs, that means the service company can go with low price. They will get a revenue because they will do a lot of jobs.
Mm-hmm.
But
Oh,
if
of
there is
course,
no volume of jobs, they need to put very high prices per job. So this is like you going to shopping mall. This is the list you select for your operation. And we need to focus on the groups. Why we put them on the groups? There is a communication group, which is, do we go with memory or we go with telemetry like real time? This is the communication group. Correlation. How we correlate, how we make sure our logs are on depth. We use either gamma ray, we use either CCL, or there is one tool, like one piece of tool, let's combine them together. CCL is casing color locator. So just we need to remember what I'm talking here. All this lecture is for producer or injector wells that have casing. I'm not talking about open hole logs. All this lecture is about cased hole logs. So CCL will be useful if you want to correlate with the previous casing when your gamma ray is not so clear. Maybe you have a carbonate formation that just look like all over the same, all over the interval, but you have some kind of special completion equipment near from each other. You can't catch them using the CCL. So this is the group for correlation. So you need one of these, you need one or two of these. A fluid identification. Okay, this is this is really tricky. Quartz pressure and temperature, acoustic density, radioactive density, capacitance. Radioactive density and acoustic density, these tools will see the density of wellbore fluid that's producing or static in the wellbore. Capacitance will see the dielectric of the fluid in the wellbore, which is like a 0-1 tool. It either seeing water or hydrocarbon. It cannot really distinguish hydrocarbon from gas. It's also called water hold-up tool. And I will come one by one for the important tool. Quartz pressure and temperature. They put it with the fluid identification tool. Anybody can expect the reason why they put the pressure with the fluid identification tool? It's tricky. Okay. So what's happened here? They put the pressure because if you take the pressure derivatives, which has happened many times, sometimes your density tool is failed, sometimes you don't have your trust your density tool, you said maybe it's not calibrated or something. So you take pressure derivatives and you create something so-called density from pressure derivatives. So pressure can be considered as a fluid identification tool. Temperature actually can be considered with the flow meter. Nickel joint, which is something you put in the horizontal wear, something like that. Flow meter, okay, which is to see the flow rate, this is the important piece of production log. This is the one who will decide the rate for you. The temperature can't be put in this compartment or this group. The reason for that, the temperature log can pinpoint the production zone. And if you take the derivatives of temperature log, you can easily see your producing zone. The problem with even there is functionality in the Emeraude, you can make the flow rate division based on your temperature log. However, the problem with the temperature log, it's a blind. It cannot see where is the movement. Is it inside the wellbore or outside the casing in the annulus, or even in the formation? So the flow meter, the next group is the flow meter, which will sense the flow rate inside the wellbore, the flow rate that comes to the wellbore, the flow rate that is taken by a thief zone, the flow rate in case you are injecting, it's called intake. Where does it go to which pair? In case you are producing, it's called inflow. Okay, and the flow meter will give you the unit in RPS, which you need to transform to a velocity value using something called spinner calibration. We'll talk a little bit about that one in the next slides. Calipers are centralizers. You need to centralize your tool in the middle of the wellbore. You cannot keep it ranking on the low side of the wellbore. So how you do that? You have a caliper which can work as centralizer, and also it can read the wall diameter, inner diameter. And there is a line centralizers which can be roller or rigid. Roller is more useful, if especially deviated well. So we'll go quickly for the tool one by one. As we mentioned, gamma ray, CCL. Okay, one second. Let me check if I want to add something. No, we are in good shape. So gamma ray, CCL. As aforementioned, gamma ray CCL is used for depth matching and correlation. It can be run on SRO, surface readout, a real time or a memory. Okay. Acoustic density is record the wellbore fluid density using high resolution vibrating tuning fork. This tool is mostly good in most of the well, but it has some limitation if there is a lot of gas present in the wellbore, it will affect its reading. Also, it's affected by temperature sometime. The privilege of this tool, it do not have any source, radioactive source. We need just to read the wellbore. So even if you have radioactive density, it will be weak source. You don't want to read the formation density. You want to read the wellbore fluid density. What's happening in the wellbore? This is the goal. So if anybody thinking about open hole logs, you just need to forget about them right now. So this type of tool is good. It do not need the pre-job calibration like radioactive density. Master calibration each few years is more than sufficient. Fluid capacitance, as I mentioned before, this is sometimes called water hold up tool. It's carried like a 0-1. It's read like there is a water, how much it's count per second. Hydrocarbon, how much count per second. Maybe the small difference between gas and oil. The limitation of this tool, when you have a hold up, increase 40%, this tool will not read sufficiently. It's cannot be used actually. Quartz pressure and temperature. This is the most common sensor, and this is the same sensor. The same sensor will be used to record the pressure buildup or pressure fall off. This is the full bore spinner, which is the, as I mentioned, it's the important piece of the PLT string. It will measure the round per second. Then it will be this reading transform using special analysis practice to velocities and volume. This type is called full bore spinner because there is another type. It's called, one second, called Al-Hilali spinner, and there is another type called continuous spinner. This is the most sensitive tool and most recommended to use whenever the wellbore condition is allowed to use it. This is the backup spinner, which so-called Al-Hilali spinner, put in the middle of the string. And this one is called sometimes turbine spinner or continuous spinner. This one usually used in restricted hole when you want just to log inside a very small tubing, and when you have injector that may collapse this one. This is the XY caliper, which record the inner diameter, which is X and Y. So 2 arm in the X direction, 2 arm in the Y direction. And this is the centralizers. You can see there is a roller here. So this is a roller centralizer. Dr. Ahmed, hello?
Yes, hello? Yep.
Yes. So I want to make sure everybody can see this video. I make this video in the workshop, so it will make it easy for everybody to understand what is a PLT string.
Okay.
I will run it out just to make sure it's working. You can see it's working?
Yes, I can see it.
Okay. So this is the PLT string. If you see it, it's done for you.
Okay.
What I was talking about is all explained here. So this is the centralizers. This is okay. This is the full bore spinner. You can see this is the full bore spinner type. You can see how its fan can be rotate easily. It's a very short video, like about 1 minute or 2 minute video. You see? Usually when a field engineer go to the field, he will take 2 string. In case one of them is failed, he have a backup string. So he take two set. Okay. So this is the Al-Hilali spinner or the backup spinner. In case the big one is failed, this one keep working. You see it's have also a fan inside it. And this is my hand. Okay. Let's see. You see how it's rotate only from the from the wind. You can see it's easily. The threshold is super low. So what's happening? There is no XY caliper connected here. They didn't connect it here. Actually, the other tool mostly connected here is the tuning fork. Have been connected, the temperature sensor and the gamma ray sensor, but you cannot distinguish them because all of them look like one piece of metal. If you see this one, like the size of this one is just 111/16. How it becomes 111? It can be collapsed. This is what we call collapse. You see, when it's enter a well bore, it's collapse. It's meaning closed. And when enter the casing again, it will be open. Not by electronically, mechanically. Just by you see, it can collapse easily. You can collapse it. When you push it in the tubing, it will be collapsed auto. Okay. So
Mazen, during
yes,
this
please.
measurement and when you run these tools downhole, did
Yes.
you stop the flow for the well? You close it?
No. No, you don't have to.
Okay.
Let me back. Let me back again. 1 second. Did you see this?
Yes.
The one in the middle is really good photo. So this is the wellhead.
Okay.
This is the wellhead. Even it is super small. This is the wellhead. No, actually they didn't put it on the wellhead yet. This is the wellhead.
Yeah.
So what's happened? They will put the PLT tool inside this string, which is called risers.
Okay.
And you see it's like a crane, and the crane will move and put everything above the wellhead.
Okay.
And they will connect it with the wellhead. There is a small valve here. After everything is connected, they will open that valve and they will run the tool.
Okay.
No need to shut in the well.
Okay. But usually in the field, always you keep the flow.
You don't want to lose money usually,
Okay.
especially
So,
for producer.
okay.
But and even for injector. But you shut in the well if you want to make pressure buildup.
Okay.
Or shut and run or pressure fall off. As you will see, I put some example for the shut in the well.
Okay. Excellent. Thank you.
Okay, thank you for the question. Really good one. Anything else about the tool from you, from the student? Anybody can ask any question, no problem. Okay, let's move then. So, preferred analysis software. In the market, there are several PLT software. There is something called Plato, which is used by BP and Shell. As we mentioned before, the integrated PLT analysis have been integrated in Geolog, Techlog, and IP. Even I didn't see anybody like use this open source software to make the PLT interpretation, but the Plato is famous one. However, I will focus in this lecture about the Kappa software. As I mentioned before, they are fully integrated for reservoir analysis. So this is the interface, the screen for the Emeraude, and you can have more. I will share the lecture after the webinar, the PDF of the lecture. You can press on the link here, and it will take you to Kappa software, and you have more information. However, this is the Emeraude user interface. You can load your data here. You can see your data after loading. You can make your interpretation using this step one after each other. Maybe in the future, I can make like small lecture about PLT interpretation for one injector, one producer. Preferred software for pressure transient analysis, which is one of the strongest software in the market, is Saphir. This is the user interface for Saphir software. Also, on the left-hand side, you will find the interpretation step. You will load your flow rate, you will load your Q, then you extract your derivatives. Then the software start to make the pressure derivative plots. This is log-log plot, this is semi-log plot, or what you call Horner plot. And this is the original linear plot between pressure and time, test time, and flow rate and taste time. And this is the results. After you finish your interpretation, you can find in front of you. Similar to Emeraude, there is Pi software, there is PAN system of other for this Fekete of IHS. However, this is the most famous one because also it is integrated with the reservoir package or reservoir workstation. So more information, more training, more videos, tutorial. You can ask for license. You just go to Kappa, press on this link, and you find tons of these things. I put also practical reference in the end of this lecture. So what we meant by production logging and pressure buildup operation. What we do in the field. So this is our well, which have been perforated. There is a casing and there is a cement, and the well have been perforated in several zones. So what we mean by PLT pass. Actually, I created this. Most of this lecture I have been created especially for this webinar. One of the guy one time asked me, what is a PLT pass? Pass is the set of data we get from the PLT tool during running the PLT in the hole in a direction. Hello? Maybe the voice is gone?
No. I can't hear you.
Ah, okay, good. Okay. So we run PLT in the direction. Okay. Pipler, which was employed by Schlumberger, he created something called multipass interpretation method that had been done in 1982. I have asked some engineer which done hundreds of PLT interpretation. I asked them, why we do multipass? Why we don't make one pass, two pass? They said, oh, it's market standard. We need to make multipass. Actually, it is not a market standard. It is a method created by Schlumberger in 1982. Maybe somebody come and will change this method. Nobody know, you know. So one of the reference I really like, which is available everywhere, is Dr. Hill, 1980, chapter 6. He put extensive explanation about the theoretical basis about this method. Operation-wise, what we need to do, we need to get standard like 6 passes, 3 in up direction, 3 in down direction, each pair with the same speed. To create something called spinner calibration. What is spinner calibration? It's a plot which transforms the round per second, the reading of spinner, to a velocity reading. A round per spinner with the cable speed, we create some kind of cross plot, and this will transfer to velocity, which can be multiplied by the inner ID to get the to get the flow rate. Oh, come on. Okay. So this is a PLT pass. So now the animated one will show why it is not animated. Okay.
I think I can see something.
Yeah, but it's have to go down and go up. For some reason. Now, you see, this is a pass down and this is a pass up.
Okay.
So what's happening in this movement? We record 2 passes, one down, one up in the same speed. Down, it will be positive speed with the depth. Up will be negative speed. We will repeat this one 2 times, but in different cable speed. For example, this speed was 10 meter per minute. This 2 speed, down and up. Then we'll do 20 meter per minute. down and up. Then we'll do 30 meters per minute, up and down. In this case, we will have 6 passes, which will be enough to have like a robust interpretation. So this is what I mentioned. We need to extra 2 pass. Okay. to record the pressure build up or pressure fall off, we'll use the same tool. After we finish our passes, we do that. Our passes down, up, down, up, down, up for 3 times. We will park the tool at what's so called the stabilization level. We'll keep it there. We will shut in the well and we will record. It will be record auto. It will record the pressure buildup or the pressure fall off for injectors. It's clear? This operation, like we do a PLT passes, it's not important, it's producer or injector. It is same operation exactly. There is no difference. In the tool, there is no difference in operation. It's exactly the same procedure. You will go, you will make 6 passes, then you will park your tool at agreed level. I hope that's clear.
As in, can you notice if, for example, if we assume the well is producing with high flow rate and maybe the oil is viscous, is this tool heavy enough?
Yes.
And if
How
there is
much high flow rate? How much high flow rate?
I don't know. I'll just assume. And
I
what is the weight?
we run. Okay. If you have a really viscous tool, this tool will not rotate. You need totally different tool to, yeah, not even a flow meter. You need something different to sense your flow rate. If you have very high viscosity.
Okay, because you want to make sure. Okay. Sorry, I think because you mentioned something, you need to make sure it's going straight without any deviation, correct? Because that can affect the measurement.
You can consider this is a deviated well.
Okay.
Till 60 degree, same procedure.
Okay.
Till 60 degree, there is same procedure. You run, maybe this has been conveyed by silk line, wire line, cold tubing, there is no difference. Procedure is the same. 6 passes, 4 passes. Then you stop at agreed level above the perf, like one is short, 5 meter to 10 meter above the perf, and make the pressure build up.
Okay.
If you have viscous fluid, you will need to use maybe temperature analysis to see the contribution, or noise log. Noise log is do not have flow meter. This is sometimes we use it like to see where is the exact, to confirm the flow meter. If you have, there is actually a reverse situation to the one you mentioned. Some of the well producing 500 barrel, 400 barrel, you know, the flow meter will not rotate, by the way. This is super low flow rate. It's even below the spinner threshold. Maybe this spinner needs 50 barrel to start rotating, 70 barrel to start rotating. So if you have low flow rate and you don't get all, maybe this one 500 barrel, okay? But this 500 barrel will not come from this perf only. Maybe 50 from this one, 20 from this one, 50, 20, 150. So the spinner, and sometimes it cannot see all these small production, but the temperature can see. Can see these small. So there is some kind of interpretation can be based on what's so-called high precision temperature with the spectral noise tool. You can use such kind of tool to detect these low flow rate things. Or in your case, as you mentioned, like viscous fluid, which is good. We have actually some viscous. I saw that in one of Amara field. When you put the spinner at the stabilization level, it is stuck. It's not rotate. It's a stop. Because even at stabilization level and you're producing, you have to see on the logging screen, this one keep rotating, not to stop. So you need to go down a few times, clean it, then you record again. Okay. Any more question, Dr. Ahmed?
No, all good. But it's good to know this.
Yes, yes. Okay. Field data output. Okay, let me just back again. Wow. So you run your tool. What you will get? What kind of data you will get? How the data look like? So whatever convey method you used, silk line, wire line, coil tubing, we must have the same data set. The same. There is two data sets, one for PLT and one will be used for pressure transient analysis. In this case, as interpreter, I don't care how they convey this tool. I want my PLT dataset and I want my PTA dataset. So PLT, you will get lasses file, the passes that we go up and down, the passes in lass format. I need at least 6 of these lasses, 3 up, 3 down. I'll show you next slide what I mean by lasses. For PTA, I need an ASCII file, Excel file, LAS file for the full pressure recording at stabilization point. So I need one single file, So PLT passes, 6 lasses. I put an example like for choke 1. You change the choke, I will go for multi-choke thing later. So what's happened? You make a PLT, you will have 6 passes. So speed 1 down, speed 2 down, speed 3 down. So this one with this one, this one with this one, this one with this one. 6 passes. What is inside this file? I will have the depth, line speed or cable speed. I will have the spinner, which is called flow meter. I will have the pressure sensor, temperature, the L-line flow meter, gamma ray, CCL, and line tension. Also, you can get the density, capacitance. Okay, unfortunately, I put maybe Wolf, that was injector. You will have density data, you will have capacitance, extra curve, like curve. So you will have the curve versus depth. So PLT passes is data, whatever data there, versus depth. The data you get from each PLT tool. Pressure versus time, which is you need at stabilization point. You will get one single file. One of my duty actually is to create this file. It is not easy to create it. The field engineer come and boop, he will give you all the time he record, maybe 5, 6 file, and in track format. You need to compile them to get something like that, okay? Or maybe easier, just like 0, like it's record 1 second, okay? It's record 1 second. 1 second step. By the way, for this one, the difference is 10 centimeter usually, which we call the step. The difference between each record is 10 centimeter. For pressure, usually the difference, it is because it's versus time, it's 1 second. It's increasing 1 second. The minimum data is a pressure with time from 1 till the end. So this is an example for the input data for a producer well data set in Emeraude. You have line speed, you have spinner data and RPS. This is gamma ray. You have your temperature. This is the fluid density, capacitance, pressure. This is the CCL, which is not really good, and the line tension. Dr. Ahmed, hello.
Yes.
Yes. تقدر تقول you can say where is the producing zone. I didn't put the perf here, but you can check where is the producing zone. This is the flow meter. It was 0 here, parallel on 0, and it's increasing here. So most probably this is not most. This is the. It's not most probably. This is the producer zone. You can see even from the density, it was reading 1 near the water zone. Oh, sorry, not water zone. That water sump. It is like below the perforation. then it is drop because of oil production.
Okay.
It's producing, density drop,
and what
capacitance
about the top, the one, and even casing there, and there is no pay zone, but it's still recording?
What do you mean by record? You mean here?
No, yes.
Okay. Because I didn't put the perf, usually the recording will be done only for perforation zone. You want to see what is happening in the perforation.
Okay, so this one is just for pay zone?
Yes, usually only for the, actually not pay zone, only for the perforated zone.
Because there is flow only from the perforation. Yep.
Yes, you want to see what's happening in the perforation.
Okay, so here you are saying, you're saying you have the formation, open hole formation. Is it casing? Is it casing, correct?
All this lecture is casing.
It's casing and perforation. Okay.
Yes, all this lecture. There is no open hole.
No open hole. Okay, yes. So this is during all perforation, and saying maybe this is producing, and the other one maybe there is no flow from this one.
Yes, unfortunately I removed the perforation. I need to put, let me put a note. Which slide is this one? 28. Okay, add perf. Okay, so maybe there is a perf here, maybe there's perf here, but it's only producing from one single zone. There is small production here. You can see that from spinner, from temperature drop, it's producing cold fluid. So production here, and that's all. What's producing? For sure, it's oil. There is no water. If it's water, we'll see an increase in density. Everything is oil. Okay. This is really important one. So what's happened? We stop at the stabilization level during the choke one. Why we called it stabilization? There is a reason we called it stabilization.
Sorry,
because
sorry, Mazen, to interrupt you.
Yes.
So is that flowing pressure?
Oh, yes.
Is it flow pressure? Okay.
1 second. This is the reading of pressure gauge. It's read everything.
Okay, is the gauge in the top of the Christmas tree?
No, the gauge is here.
Okay.
The gauge is here, above the perf.
So it's downhole. Okay.
Yes, it's called the stabilization level.
Okay.
We stop it there, okay, and we keep it there. Only when we do the passes, we go up and down, we back to this stabilization level.
Okay.
Okay, so what's happened? So this is the the reason to name it stabilization level, because before we do the PLT pass, the PLT tool, when it's run in the hole, it's mix the flow regime, maybe affect the flow regime. So we give it a few hours till it's stabilized. How much the stabilization? Some company, they want 1 PSI, 2 PSI per each 2 hour. Some company, they said, okay, 10 PSI is good for me, like each 2 hour or each last 1 hour. I have been faced like some company in South Iraq, they ask us to wait 18 hours till the will get stabilized before they do PLT passes. You know, some of them no, just standard, wait 2 hours, do your PLT. So there is a reason to call it stabilization. 1 second. Okay, so what's happening here? We put our tool at the stabilization level at the first choke. This is a multi-choke job. There is a gap here. The tool is now recording pressure versus time. Now the tool is stabilized. The engineer start running the tool. So he start recording versus depth. So now we see gap in the data because the tool is recording versus depth. Now back again to stabilization depth. The client changed to choke 2 and he start record stabilization during choke 2. Nice. Then he saw his well stabilized. He asked to make the second PLT run at different choke. Then back to stabilization point. Change the choke. Waiting the well to stabilize. Then he make the third PLT run. Now he back to stabilization point and shut in the well. He make pressure buildup. Nice. Choke 1, choke 2, choke 3. I will hide it. Which choke is bigger than the other one? Maybe you saw it or catch it or not. Can you say?
One.
One is bigger?
Yeah.
One is bigger. Yes, no problem. Just guess anything. One is bigger. Okay. The blue curve is a pressure. So your well have been choked. This pressure level is less than this one for sure. And this pressure is less than this one and this one. What that mean? You decrease the choking of the well. You open your well. You open. So the choke, you mean this choke, actually 3 is the biggest choke. 2 is less and 1 is the less choke. Because 1 you was choking your well and production was less. Now you open a little bit, now you open more choke. And now you totally shut in. You have boom, pressure buildup.
So yeah, it look like you are closing your well,
Yeah, this one is
gradually.
No, I'm actually I'm open. Open.
You open and sorry, you open and then you close it.
Yeah. There is a pressure drop in there. This is bottom hole flow rate, and this is the shut-in data. Okay. So these gaps, as we mentioned, this is the time. This is because of track unit. When you record PRT, the engineer will transfer the recording from time-based to depth-based. This is pressure versus time. This is not like a log, pressure versus depth. However, these data of this plot will be used in PTA analysis. Okay, okay. Any question? No problem. Yeah. Before I go for an injector.
Okay, so for choke 1, so is the well was closed, like or it was open?
No, it's open, but at little choke. Maybe 32 over 46, 64. Maybe this one is 56 over 64. Maybe this one 64 over 64.
So what you were doing is like increasing the choke? I mean, reducing the choke and then you just...
Yeah. I'm increasing. You see the pressure is dropping.
Yeah.
That means I'm getting the choke bigger. You know? Then I choke the well. Pressure build up.
Yeah.
And I will use this. It looks like you have a valve and you keep opening.
Yes, exactly. I put here. This valve is on the surface. Actually, the choke on the surface is adjustable choke. You can't just increase little bit by little bit. Adjustable choke.
And then you close it.
Then you close it to make the build-up. All this recording done by the same PLT tool, the pressure sensor tool, at the stabilization level. Okay, this is injector. You can see the data for injector. This is Emeraude software. You load the data. You have line speed. You have your temperature. You have full bore spinner, line spinner data. This one I put the perf. Okay, fortunately. You have your density. Everything is water. Then increased here. Why it is increased here? Because this is the dirt in the well bore. It's called sump. Okay, this is a most probably completion fluid. You have your CCL, and you see there is a huge spike in the CCL here, and here, sorry. And it's come exactly with the places that the flow rate is decreasing. You see the flow rate in minus. Let me back to the producer so you can compare. You see the producer, you can read it from down to above. It was 0, parallel on 0, then it's increased, becoming positive, then it's increased more. For injector, you read it from above to below. It was in minus because you are injecting from above to below. Then it's here, it's drop. This completion is called SSD, sliding sleeve completion. You heard about SSD? It's not like a tubing. It is a tubing, and it's have a window you can open, sliding window you can open mechanically. So you can control your injection. So there is a small window here. You see the CCL catch this window, XY caliper catch this window. Everything is giving a spike in front of this small window. And you see some injection going there. Nothing, maybe tiny injection going to this window. I can see there is also a small window here. And all the injection is going to the latest window. You see? From XY caliper. What the temperature difference here? Anybody can see the difference? You see, this is the producer temperature. It's going, and there is some cold entry here because there's some production here, and there's small here, and there's some cold entry. So you see there is a change in the temperature. But for this temperature, it's like a flat. And it's very minor, only 32 degrees. I'm not sure in Australia is Fahrenheit or Celsius, but this is very low temperature. The reason for that, because you are using injected water from surface. So everything on the same temperature. The jump in temperature, that means the injection is stopped. And the well is back to geothermal below that level. That means nothing of the water is going to this perf. This perf is behind the tubing, and this perf is also behind the tubing, and this one is behind the tubing.
Mazen, for injectors, they usually do this test just to check if the perforation was blocked or not.
Okay, actually,
what is the main reason they do all of these tests in what do you call it, injectors?
Okay, maybe I will change this example in my next lecture. Actually, I put a very complex completion, not very complex, but it's complex completion.
No, but it's good to know. No, perfect. It's
good
to know.
Maybe I have to use something similar to that completion, like a perforation, direct perforation. This one, this type of completion, there is a casing, have been perforated, then they run a tubing inside this casing, have small window, controllable window, so they can control the injection. What the client want to see, which of these small windows is this one, and actually there's okay, this one, 1, 2. There is only 2 SSD, this one and this one. Okay. And the black one is a Packers.
Okay.
Is a Packer. This is a Packer and this is a Packer.
So there is a tube. Just to hold the tube.
Hold the tube and isolate this perf.
Yes, exactly. Okay.
Okay. So what's happening here? This one is isolated. There's nothing go there. This one, this SSD number 1, there is only tiny injection going to this SSD and distributed on these 2 perf. Tiny is nothing. So that means these 2 perf actually is taking maybe 10% or 5% of injection. All the injection is going to the lower zone. But here is the thing. You cannot say where is exactly the injection is going behind the perf. Like, let's assume this is like a 20-meter perf. You can see only the injection is going through this, but how it's distributed in this one. You will need some kind of so-called also spectral noise with high precision temperature can see behind the tubing. Maybe you will do it in different lecture.
Okay, no worries. Thank you.
Okay, so the injector purpose is similar to producer. In producer, we called it inflow. You want to see the inflow zone. It means the zone that's producer. For injector, you want to see the intake, the zone that take the fluid. Okay, okay, but actually, okay, 30. This is also a multi-rate injection logging tool. When I say ILT, PLT, it's just to distinguish between injector and the producer. But the tool is still the same. There is no difference. You will run the same string. Maybe some client, they said just remove the capacitance and density. We don't need to pay extra money. But it's not important because it's water. There's nothing, only water. So if you remove the density and capacitance, you will lose you can still make a very good interpretation. However, this is an example of multi-rate ILT plus pressure fall off. Just I want to back to this one to see the difference. There was choke 1, choke 2, choke 3, and pressure buildup. What's happened here? There is injection 1 because we are controlling the injection from surface. Then we increase the injection. Then we increase the injection. The blue one is the pressure. Then we shut in the well, and the pressure drop or fall off. Because of that, it's called fall off, an injector. Because after injection, it will drop. And you can use these data exactly in the same way using the pressure buildup to get K, skin, whatever from the PTA. Exactly, there is no difference. The Saphir software, he can understand directly this is injector. He just put everything in minus and the result will be the same, the final result.
Mazen, you
Yes.
like to take a break and we back at 4?
What time? You mean 10 minutes?
10 minutes.
Okay, but let me just finish this page. Just finish this page. Okay, so injector 3 bigger than injector 2, bigger than injector 2, bigger than 1. You can see that from pressure increase. And this is what's so-called multi-rate ILT with the pressure fall off. And the gaps is because the engineer changed to depth recording with the PLT. Okay, so we'll stop here, the benefit. Okay, let's take a break for 10 minutes. But keep the recording, Doctor.
Yes, sir, I will keep the recording. Thank you.
Okay. Okay, thank you. We'll wait for you.
Hello?
Hello, doctor. I'm ready when everybody is ready. Do we start again? Continue.
Hello? Yep.
Okay. So, hello again. So this part is the critical part of this lecture. What I'll try to present here, what is the benefit of doing the PLT passes with the pressure buildup or pressure fall off. One of the benefits is to have a precision estimation for the flow rate, especially for producer, before the PTA analysis. So we'll have a precise rate can be used, precise rate from the Emeraude analysis can be used in the Saphir analysis. This is one of the benefits at downhole condition. The second one, you will have all these data, PLT, PBU, PFO, using the same set of a tool in a single run. No need the separate run, no need to spend more time or rig time. If a wireline real-time convey analyze, this will have a real privilege to monitor your PBU, PFO progress. I saw some major clients doing the pressure buildup or pressure fall off, especially pressure buildup, real time using wireline, even so they spend more money. So they can get a data each 2 hours from the wireline engineer, and they can put it in the Saphir software to monitor the progress of the buildup, to see if they have sufficient data. They pass the wellbore storage, they pass the wellbore effect, they enter in the reservoir area. They want to have so when they have a sufficient data to make a robust PTA analysis, they will ask the engineer to stop. They will not have this privilege if they have a memory tool. And memory tool, they need to guess based on their field knowledge. They said, okay, make the build up for 2 days, something like that. But when they have a wireline, no, they can't monitor real time. So the field engineer will send by email this single last file each 2 hours to the processing center of the client or the final user, and he will monitor the PTA. Okay, having a PLT run before PBU or PFO will give a clear idea about the downhole inflow or intake condition. Are you producing from a single perf zone? Are all the perf zone is producing? What is the rate of each layer? What is the intake layer of each layer? Are you injecting in like in a single meter and you create like some kind of fracture? So when you make your build-up, you don't guess. You don't guess, okay, I expect to see different skin. I expect to see, I have been simulated. I don't expect this. What's happened? Sometimes the result of PTA is ambiguous. So in this case, after you make your PTA, you start to question what is happening, and you need to go and run a PLT. You need to ask like the wireline company to go and make a PLT run. You need to pay for rig up, for mobilization, for everything. Even you can't do that in the first place. One of the recommended practice, which I read about, it's better to agitate the formation at different rates before make the pressure buildup in a pressure buildup. So having a multi-rate, you need to have a PLT tool to estimate each rate in a precise way before the PTA analysis. Okay, if we go more advanced, whenever you have a multi-choke PLT executed, we can create something called selective inflow performance. I believe everybody in this group know what is IPR. Okay, it is inflow performance relationship, which is the relationship between the pressure and the Q. You can get like P initial and open, absolute open flow. What we can do if you have a multi-rate PLT, multi-rate operation with a shuttle run, you can create this IPR relation per each zone. You can do that per each zone. And this functionality is available in the Emeraude. And you can get P star per each zone. This can take us to extra step. Now you have the rate per each zone. Now you have the P initial per each zone. So you can make a PTA analysis with a multi-layer model, because you can enter each layer flow rate. You can enter each layer P initial. Going further, you have now your IPR relation per each zone. You have your open hole logs already. You have your flow rate per each zone. Now you can create some kind of dynamic permeability model to refine your static permeability model that you can get from open hole. This has been developed by Chevron. There is an SP paper. I put it there. And this functionality is also available in the Emeraude software. So this is the most simplest form of the integration. You have PLT interpretation. This is example for injector. This is the result of PLT interpretation. You can take the rate, the total rate from here, and you can put it in the Saphir analysis, and you can make your PTA analysis. You have your PLT analysis. You understand, you see, there is a lot of perf, but you inject only here, here, and here. That's all. Everything else is not taking anything. You can see that from flow meter directly. And you can take the total flow rate, use it in your PTA analysis. Little bit extra integration. You have multi-rate analysis. This is the Emeraude result for multi-choke. This is the same 3-choke we saw for before a while with PPU. And this is the inflow relationship per each layer. You can take them both. You have the P initial high, and you can create the multi-layer PTA analysis by Saphir.
Sorry, Mazen.
Yes.
I just, because maybe it's good for the student. So you are controlling the flow rate by choke, correct?
Exactly.
Okay, so why you need to make it different flow rate?
Okay, this is a good question. First of all, they want to see the performance. This one, the IPR.
So for IPR, okay.
Yeah, yes, they want to see the. Yes, they want to see the IPR. This is one benefit. This IPR will give them the P initial and the open. I cannot. What's the name? The AOF, open, absolute open flow. You called it this intersect with the X line.
Okay, and usually how many flow rate they go? If they go for more flow rate, more different flow rate is better actually.
Okay, practically 2 with 1 shut-in or 3 with 1 shut-in.
Okay.
Practically. For PTA, if you have 3 or 2 flow rate, it will be really good PTA analysis. Because what's happened? Let's assume you are producing at single flow rate for a long time. You didn't agitate your formation really. But when you make different flow rate, maybe increase it, you agitate some kind of different pores in it.
Okay.
So the pressure wave will be changed, will agitate the formation. You know, you'll get more information from the data. Okay, so this is the multi-rate PLT. You have the flow rate per each layer. You see each layer. You know, this one is producing blood. This one is producing blood. Okay, and then you make your inflow performance. You make it above each perforation. You can combine all this in a PTA analysis, and you can create multi-layer PTA analysis. Actually, what I'm talking about this one is not junior level, is not what you called it, associated level. It's mean like a little bit, but it's intermediate to advanced. Like usually they give it to experienced people to make such kind of analysis.
Okay.
To make this. This is the extra step advanced analysis. Now you have your multi-rate PLT analysis. This by Emeraude. You make your SIP selective inflow performance or IPR per each formation by Emeraude. You make your PTA analysis by Saphir. You get the skin, you get K. Then you refine all this in what's so-called APERM or effective permeability model. This also you need to back to Emeraude again, like 2 by Emeraude, 1 by Saphir. Take all these results. Kappa give you the liberty to make all that in easy way. You just export from here, import to there, everything is there. And there is a videos in Kappa website. You just go there and you will find how you do that. There is a training documents also. Okay, so that was some kind of benefit for integrating PLT with the PTA data. Okay, what usually we put in the final report when we make our report? Unfortunately, I couldn't find any report to share, but I'll try, like I put like the content. We put the operation summary, what we did in the field. We put some kind of log quality check. This log is good, this log is bad, this data is good, this data is bad. And usually they put from scale sometimes from 1 to 10 or 1 to 5. We put the plot that we aforementioned for a while, stabilization plot. We make our result summary, observation, what we saw, conclusion, what we conclude, and what's our recommendation for future runs or for this well. This is duplicate. Let me remove this one. Page 39. You put the wall sketch, you put tool sketch, you put wall log header, sequence of events, and fluid properties PVT that have been used in the analysis, in the PLT and PTA analysis. So this is the most common report sequence. Usually, if any of your students have been work for a company, there he will find some kind of reporting format he will follow. Most probably will be similar to this one, especially in service company. Final soft data delivery. We make the interpretation by Emeraude. We make interpretation, but by Saphir, we compile our report for plots and table. Okay, what we will deliver as soft data? Like if we want to take this data and plot it in different software. So final soft data can be divided into groups. The Emeraude output and the Saphir output. The Emeraude will give it the PLT analysis as last per each choke. Also, we need to keep in our record the Emeraude file. The final, we called it final Emeraude file. We make a lot of interpretation. We send it to the senior guy. He check it. He back to us. We reach to the version 10 or something, and we said this is final. We send to client. He approved. This is final. We keep this one in the record. So maybe somebody come after 2 years. He want to check our work. Double click, and he check what is inside Emeraude. Because Emeraude is like a database. You make a run in 2018. You put it there. Final. You make a run in 2019, you can just put your 2019 run and keep working on it. So you can see all the sequence of the run inside the Emeraude. For Saphir, Saphir, usually you can export some kind of class output, but nobody do that. Usually they do it as PDF to have the plots, which is log-log plot, semi-log plot, and linear plot. And you keep also your final Kappa, Saphir file, which is dot for the old version, dot KS3 or KS5, actually, this one for the newer version. Dot KS5. This is an example for what's so-called a client CD. Usually we put in folder called client CD. We put the PLT interpretation output, PLT Emeraude file, you see .ke2. Sometime we make the report as PowerPoint for easy reference, for especially for high management. You put your report as a PDF and PTA analysis output and Saphir analysis. Okay, this one for anybody want to develop his information in well integrity, in PTA analysis, in PLT. I put the links for the references here. Best place is Kappa. Is Kappa LinkedIn? Kappa, you can follow Kappa LinkedIn, and they will always advertise for their new free courses, free webinars. I attend a lot of them, usually. Free Kappa software learning, YouTube, whatever they can share, they put it later on YouTube. You can watch it for free for all their software. I didn't talk about all their software. They have a lot of software, simulators, rate analysis. Kappa website, you will find tutorials, you will find the videos, you will find documents. You can ask them to send you a free license. Okay, and now they have some kind of free program, like a webinar series. They used to have some kind of webinar called the Big Shut-in, which is focused on PTA. Now they have something called well integrity monitoring, several of series, like 2 hours to 1 hour webinar, which is really good. They have learned something new, which is multi-webinars on different things like Emeraude, Saphir, others. And they have continuous G-Life webinars. You just click on the link and they will send you the list and you can watch them, or you go there and select whatever you like to get. This book, which is updated on yearly or bi-yearly base, this book is the most powerful book in the industry, written by surface matter expert in reservoir engineering integration. It's really, really good book. I always have a hard copy for the latest one. I put the hard copy usually because this one is amazing. What's happened, these guys that they create all these softwares for reservoir engineering, for reservoir surveillance, for reservoir monitoring, they combine the theory work with the practical work, and they update this book on regular basis each year. Now there is 2020 version. I put a link and you can download it for free. You can contact me on my email, and if anybody wants to join my LinkedIn, he can send me, he can click here and send me an invitation. And that's all. Thank you.
Thank you so much, Mazin, for the nice lecture. It was amazing, actually. For me, I learned a lot. It was a pleasure to have you here.
It's my pleasure. It's my pleasure,
thank
Dr.
you,
Ahmed.
we,
Yeah, I hope all the best.
Yeah,
for you and for your student. I hope to send me the recording after we close.
If I figure it out.
Just don't lost it. I believe there is a way, okay, to keep the record. I don't know how.
I done it long time ago. Yeah, let's check. Guys, anyone have any question?
No.
Okay. No worries.
Thank you very much.
Thank you. Thank you.
Okay, Mazin, I have a question.
Yes, please tell me. Yeah, no problem.
Okay, what about Did you done any analysis during well logging or well testing regarding to the fractures?
Fracture, okay. Usually for some PTA in Iraq, we saw the fracture behavior in PTA after some kind of frag job near the wellbore. And the signature, you will see it on your pressure derivative plot very clearly. When you make the build up, it will be like a fracture behavior.
Okay, yes, okay.
But that was induced fracture, induced like by the operator using a frag job. But it wasn't natural fracture.
But what about well testing, or is there any special tools in well logging to detect the fracture?
Encased hole?
Yeah.
Yeah,
Encased hole
okay.
or open hole?
Okay, because in open hole mostly you can use the image log. You can use the image log, which is a good technique to detect fracture. You can use the new acoustic dipole log to detect fracture sometime. And for cased hole and open hole also, you can catch a fracture using a spectral noise log. It will give a special frequency if there is a fracture. I can send you some document about this tool, which is used also to catch any fracture. Because sometimes for injector wells, you are injecting in sandstone. You don't expect to see any fracture in South Iraq or in this flat area. There is no tectonic move.
No, but in South Iraq, most of the carbonate are fractures.
Not really, because there is no tectonic move to push to create fractures. This is the thing.
I'm
Maybe
talking about nature.
but in North Iraq, there is really a lot of fractures. There is really. Usually in South Iraq, there is maybe vugs, a lot of vugs.
I know, yeah,
Especially
bugs a lot, yeah. But there is a
yeah,
fracture. I
but
think they produce it from fracture. I don't know, but I'm sure about it. There's a
from
fracture.
the one, maybe a little bit, not really a lot of, because measure formation is really huge one, but there is not really fracture system, big one like the one in the Kurdistan of Iraq.
Okay, because
Kurdistan,
of the,
yeah, of the move. So what's happened? Sometimes, like in Zubair, it is sand, it's flat, there is no tectonic, but because of injection, you create a fracture. So
because
of injection. So what's happened? They run this spectral noise to catch. Okay, there's a fracture here. There is a fracture here. You know, sometimes even by PLT, you will see you perforate 100 meter, and all the injection is going to 2 meter, like 5,000, 10,000 barrel. You can imagine is going just to 2 or 3 meter. Because
what about the azimuth of fracture? Can they detect the direction of the fracture?
Direction of the fracture. Well, I'm not sure about this one really, but maybe the acoustic one. Because if this one is related to geomechanics, which is not my thing, but if this one related to geomechanics, the best tool to study the geomechanics is the cross dipole acoustic tool. This one have a lot of application in geomechanics.
And this one run by who?
Run by everybody. Yeah, by open hole logs. You can run it in cased hole, but you have to have a super good cement. So the signal of the sound can reach to the formation and back to you. But usually now everybody is running like a standard tool with the open hole, usually. But no, actually nobody is using its benefit, you know, because what's happened, the study is traditional. Oh, this is sonic, something, delta T. Everybody's using this simple equation. But big company, they know its benefit, you know.
Okay, and have you done any temperature well test?
Temperature well testing. If you see, I get your point. Like if you see, I'm just let me.
I saw one of them that's logging the temperature. Yeah.
Okay. And this one. You see this red curve?
Yes.
This is the temperature.
Yeah.
So usually when they make this stabilization plot, they keep the temperature log recording.
Okay.
And I saw in Kappa website, even this one, you see there is a temperature, but the scale need to be amplified. This one is really tight scale, like it need to be only 2 or 3 degrees to see the change in temperature. I saw in the Kappa website, either you use Saphir or I'm not sure which software, or the other one, I cannot recall. You can use it to make temperature transient analysis. If that was your question.
Okay, yes, okay.
Yeah, there is something similar. You can do it also by this great Kappa things. They put it there. These guys, I don't know.
Yeah, they update, yes, they always.
Goro, you know,
yeah.
Goro of reservoir engineering. And by the way, if you are using your official university email, they are so cooperative. You can ask them anything, they will back to you. You know, they are really open for these things. I saw them, I forget to put this one in the presentation. I saw them, they make summer school for the students. You just need to write them. They will make some kind of Emeraude, Saphir, whatever software to your student, and they will give them a license to practice. Just if you go to their LinkedIn or website, you'll find this one, or drop them an email.
Okay,
you know, they
let's
will
see in case they have some, if they have a brand here in, you know, if they have an office
they have USEC Barnabas. It's based in Indonesia. He gave us a course in PTA before a while. So this guy is, I believe, he's responsible on Australia also. USAC Barnabas and Nicholas Cutler. Okay.
Okay, oh good. Maybe
yes.
I will ask you about their details later. Yeah.
I will send you their email.
Okay.
Email.
Excellent.
Yes.
Just any question?
No question, but thank you, Dr. Mazen, for sharing your knowledge with us. And actually, I've learned many things, and I've seen the real tool and was very interesting things. So thank you.
Yeah, thank you. I believe Sarah. Thank you, Sarah.
Okay, thank you so much, Mazen. Everyone saying thank you. Yeah.
Thank you. And I will share the presentation with you, Doctor, and you can share it with
you. Thank you so much.
Student later. Okay. Thank you. Thank you. Bye-bye. Have a great day. Bye-bye all.
Bye-bye.
Bye-bye.
We will continue. I will continue with him.